Hey Honors Chemistry students, this is Mr. Etter here, just helping Miss Carol out. That is okay. I understand that you are learning about intermolecular forces, and this lab is a great lab to show you the strength of intermolecular forces using the property of surface tension. You should watch this first video here to understand how this lab is set up and how it will be measured. It's using this caliper device, and as you separate the drops of water from each other, it's the distance at which the calipers are, the distance from each other that you are measuring. And so the farther apart they are, the stronger the intermolecular forces are holding those molecules together as a group. So when you watch the video, make sure that as you play the video, so the video plays here, make sure you click on the settings, activate the ruler. The ruler's placement is important and it's already set up here so that 0 is on the bottom, and you want to measure the height at which the liquid breaks apart from each other. You can see Marie Curie here and there. That's kind of funny. Anyways, moving on. So this first one, you are just looking at two substances, pentane and octane, and you want to accurately record the distance at which the surface tension is actually broken. Now, number 3 here, you're going to get a lot of information in this section about intermolecular forces, and this talks a lot about the London dispersion forces that are at play. So it looks at the molecules here first for pentane, and then it looks at octane, and it starts to compare those. So it compares the London dispersion forces of a smaller molecule compared to a larger molecule. So on number 4, you need to predict the strength of the London dispersion forces between decane, hexane, octane, and pentane. When you finish this section and lock it, it will unlock number 2. So now you're looking at the surface tension of various alkanes, pentane, hexane, octane, and decane. And so you're comparing your prediction to reality here. So use your data that you collect to then answer this question number 2. And as we move down here, we have pentane, pentanol. So now we're getting into not just London dispersion forces, but dipole-dipole interactions. This OH group here, as Miss Carol has probably talked to you about, the OH group creates a dipole, and how does that dipole interaction compare to the London dispersion forces? So then once you make your prediction, you then move on to number 3 to look at a dipole interaction in pentanol and comparing that to other alkanes like pentane, hexane, octane, and decane. So again, watch the video, measure the distance, record your data, and then rank them in order of weakest surface tension to strongest surface tension, with an emphasis looking at the alcohol pentanol and how that group compares. So here we look at what happens with this hydroxyl group in the pentanol molecule and how that interacts. So make sure you read this carefully. I know there's a lot of reading in this lab, but it is really helpful. So now in this table, you are comparing these new molecules, and you need to identify what intermolecular forces are present. Are they London dispersion forces, or are they, I'm sorry, it's escaping me, or are they dipole-dipole interactions? So IMF's present, London dispersion forces, or dipole-dipole interactions, and rank them in order of strongest or weakest as 1, strongest as 5. We will then compare. Again, I know this is a little repetitive, but we're comparing the distances before it breaks and looking here and actually comparing your predictions. And now we're looking at water. And at the end here, we're adding the third intermolecular force that you need to know, which has to do with hydrogen bonding. And read this information as it talks about hydrogen bonding and the interactions of those hydrogens to the more electronegative oxygens in this case. And from that, you can then compare these last three, where we have water, which has hydrogen bonding, decane, which has London dispersion forces, and octanol, which has dipole-dipole interactions. And you're comparing the strength of the different intermolecular forces between one molecule to another molecule and make the correct ranking. I hope this was helpful. Let Ms. Carroll know if you have any questions, and good luck with this lab.